Okay, in this video, we're going to be discussing the metal crystal structures. So let's begin with a couple of definitions. A crystal structure is a 3D periodic array of atoms. It contains a crystal lattice, which is a representation of the arrangement of those atoms. And what we study in depth and what we're going to see a couple of examples in this presentation is the unit cell, a couple of unit cell structures, which are the smallest volume of material that contains all unique features of the crystal structure. The unit cell, it varies from material to material, from metals to ceramics. It depends on what type of atoms it contains. It depends on how many atoms it is touching, and so on. The coordination number is the number of nearest neighbors for a specific lattice point. So how many atoms is that lattice point touching? A lattice parameter is the cube length, and it can be expressed in terms of the atomic radius r. And the atomic packing factor, APF, is the fraction of unit cells occupied by atoms. So now that we have all this basic information, all this background, we can go ahead and deeply study each unit cells, each type of unit cell structures of metals. Now, the metallic crystals are much more densely packed than the ceramic crystals because they only contain one element. And the ceramic crystals, they have cations and anions. And for that, they also have ionic bonding, which is directional. And in contrast with the metals crystals, they have metallic bonding, which is non-direction. And that also makes the metallic crystals much more densely packed. The nearest neighbor distances is very small as well because metallic bonding has low bond energy. So for all of those reasons, metallic crystals are more densely packed. So let's start with the most simple one, which is the simple crystal structure. It has an atom on each of its edges, and as can be seen, the diameter is 2r. These two atoms right here are actually touching, so the diameter is 2r. And the lattice parameter is also considered 2r in this case. The Cn, the coordination number, is 6. So this is only one unit cell. So this is only one unit cell. But when you see a whole material composed of with many simple crystals, one of these is touching 6 other atoms. Now the unit structure, the unit cell of a simple crystal contains a total of 1 atom. You can see right here you have 1/4, 1/4, 1/8 on the bottom, and then 4 1/8 on the top, and that's a total of 1 atom. And the atomic packing factor is of 0.52, which is pretty low. Now the next unit cell that we're going to study is the face-centered cubic. The face-centered cubic is a little more complex than the simple crystal. It also has an atom on each of its edges, but it contains 1 atom at the center of each face. So you have 3 extra atoms in the unit cell. So the total number of atoms in the face-centered cubic's unit cell is 4, where here we have n equals 4. The coordination number is 12. which is higher than the simple crystal. And the diameter, because the diameter is 4r for radius, the lattice parameter is going to be 2 square root of 2 times the radius. That calculation was made by professionals in the field. It has to do with geometry, and they calculated that the lattice parameter is 2 square root of 2r. Now the atomic packing factor of the face-centered cubic is 0.74, which is the highest one. It's also the same as one that we're gonna see in the next few slides, but it is the highest atomic packing factor of the metal crystal structures. A couple of examples of metals that contain a face-centered cubic structure is aluminum, platinum, gold, and copper. So next is the body-centered cubic structure. This is another type of unit cell. It contains a total of 2 atoms, and it as well as the simple cubic, it also has 1 atom on each edge, and then an additional atom in the center of the unit cell. And just a reminder, metals are composed of only 1 type of atom, so these are all the same atom. So if this is a cubic structure of, I don't know, an example, let's see, if this is a cubic structure of silver, all of these are going to be silver atoms. And the critical number is 8, so each one of these atoms is touching 8 other atoms. The diameter is 4 radius because you have an extra atom right here in the center, and remember all of these are touching each other. And the lattice parameter is going to be more complex. It's going to be 4 square root of 3 over 3, all of that times the radius. And the atomic packing factor is going to be 0.68, which is smaller than the face-centered cube. Lastly, we have the hexagon close-packed. This is the one that has the same atomic packing factor as the face-centered cubic. It is also 0.74, and it is very similar to the face-centered cube, but the arrangement of the atoms is different in the material. So in the diameter you have 2 radiuses, and the lattice parameter is going to be 4r times the square root of 2 over 3. And the critical number is going to be 12, which is a lot, which is higher than all of the other ones. And the total amount of atoms inside of this unit structure is 4. So it has a total of 4 atoms inside of the unit cell. Some examples of metals that contain this unit cell structure is Be, Mg, Ti, and zinc. And those are all of the unit cell structures of metals. In the next video, we're gonna see the unit cell structures of ceramics, which is a little bit more complex because each of them contains at least two different types of atoms.